All right, we're in section 3.4, where we're going to solve systems with linear equations in three variables. By definition, the three variable linear equations, we add an additional variable. We've seen x and y before, but now we put in z. X, y, and z are the variables written in standard form. You can see that the standard form is right here. Ax plus by plus cz equals d, where a, b, and c are not all 0. So we solve systems of linear equations with two variables, x and y. It required us to have two equations. So since we add an additional equation, or additional variable, we're going to add additional equation. And then the ordered pair becomes an ordered triple instead, and it's written in x, y, z form, which makes it a three-dimensional space. So the concepts are still the same as you're going to solve with two variables. Now we're just looking at it in a three equation setting. The first thing we're going to take a look at is we have this system here. We got 4x plus 2y plus 3z equals 1. And we got 2x minus 3y plus 5z equals a negative 14. Finally, we got 6x minus y plus 4z equals negative 1. All right, so what we're going to do is the first thing what we're going to do is when we solve this is I'm just going to pay attention to these two equations. So I'm going to rewrite this and I'm going to say 4x plus 2y plus 3z equals 1. And then I'm going to write 2x minus 3y plus 5z equals a negative 14. Now, I'm going to use the elimination method because, for one, there are no variables that are just by itself. All the coefficients are something that are either larger than 1 or larger than negative 1. So what I'm going to do is I want to eliminate one of the variables, and I'm going to choose to eliminate x from this particular system. So I'm going to eliminate x by multiplying the bottom equation by negative 2. So the top equation, which is 4x plus 2y plus 3z equals 1, and then by multiplying everything on the bottom by a negative 2, I get negative 4x plus 6y minus 10z equals a positive 28. Okay, so that means that cancels it out, and now I just combine the like terms from the two equations. So I get 8y minus 7z equals 29. All right, and I stop. Now what I'm going to pay attention to is these two equations. So same thing, I'm going to rewrite that as 2x minus 3y plus 5z equals a negative 14. And now I got 6x minus y plus 4z equals a negative 1. Now, I eliminated an x from the first two equations, so I'm going to eliminate that same variable. So in order to do that, what I'm going to do is I'm going to multiply this top equation here by a negative 3. So then it gives me negative 6x plus 9y minus 15z equals, that would give me what? 14, negative 14 times negative 3 would give me a positive 42. And then I just rewrite what I have on the bottom equation. Okay, so now again, I eliminate the one variable x, and then this becomes 8y minus 11z equals 41. Okay, so now I stopped here. Now I have these two equations. So now I'm going to have two equations, but I got two unknowns. So now I got 8y minus 7z equals 29, which is from here. And then I got 8y minus 11z equals a 41, which is from here. So all I'm going to do now is I'm going to eliminate one of these variables. So what I'm going to do is I'm going to eliminate the y, and I'm going to change all of the signs on the bottom, which makes, so it allows me to eliminate this 8y and negative 8y. Negative 7z plus 11 gives me 4z, and then 29 minus 41 gives me a negative 12. And then I just divide both sides by 4, so z equals a negative 3. So now what I have to do is I can just look at the first two equations. So now I know that z equals negative 3. I can just plug that in to the equation. So what I'm going to do is I am going to rewrite all of the systems with negative 3 in for z. So what I have to do is this. So go over here, and I'm just going to say 4x plus 2y plus 3 times it by a negative 3 equals 1. And then I'm going to say 2x minus 3y plus 5 times it by a negative 3 equals a negative 14. So this here, I'm just going to multiply the 3 times the negative 3. So I got 4x plus 2y minus 9 equals 1. And then on the bottom, it's 2x minus 3y minus 15 equals a negative 14. So now putting all the constant values on one side of the equal sign, so I add 9 to the first equation, I add 15 to the second equation, which then gives me 4x plus 2y equals 10, and then I get 2x minus 3y equals a positive 1. So now I have two equations. I can use these systems that I learned before. I'm going to eliminate the x value by multiplying it by a negative 2. So the top is 4x plus 2y equals 10. And then the bottom is going to be negative 4x plus 6y equals a negative 2. This cancels out, so now I'm left with 8y equals 8. It means y equals 1. So I know that y is 1. I know that z is negative 3. So I can go back to this original equation. And let's see here. I can erase right here. And then I'll say that 4x plus 2 times by 1 plus 3 times by negative 3 equals 1. So I'll have 4x plus 2 minus 9 equal 1. So now I have 4x minus 7 equals 1. 4x equals, so if I add 7 to both sides, equals 8. That means x equals 2. So x is 2, y is 1, z is negative 3. So that means that the ordered pair in this case is going to be 2, comma, 1, comma, negative 3. Okay? Let's take a look at this second example. Give myself some more room. There's a lot of work involved. So again, same thing applies. I'm just going to pay attention to the first two equations. So I got 6x plus y minus z equals a negative 2. And I got x plus 6y plus 3z equals 23. So you can pick whatever value you'd like to eliminate, but what I'm going to do, I'm going to choose, because I see how I have these two x's right here, how they're opposite coefficients of one another. So just to plan ahead, I'm going to eliminate the x value first. So in order to do that, I'm going to multiply this by -6. So then that gives me 6x plus y minus z equals a -2. And then on the bottom, it's going to be -6x minus 36y minus 18z. And that's going to equal, what, a -138. So this gets canceled. This becomes a -35y, and then this becomes minus 19z, and then this equals -140. Then again, I stop. Now I go over here and I pay attention to the middle and bottom two equations. So I got x plus 6y, excuse me, plus 3z equals 23. And I got -x plus y plus 2z equals 5. Now, this one here, these are already opposite coefficients of each other, so I can just cancel those out right away. And then this is 7y plus 5z equals 28. Okay, so now I'm going to just pay attention to these two equations. So now I got -35y minus 19z equals a -140. And then I got 7y plus 5z equals 28, where I got it from these two equations respectively. Now, what I'm going to do is I'm going to eliminate the y, which makes it seem reasonable. What I'm going to do is I'm going to multiply the bottom by a +5, because 5 times 7 will give me the 35, which is the opposite coefficient. So -35y minus 19z equals a -140, and then will give me 35y plus 25z equals 28 times 5 gives me 140. So I get here, this becomes my eliminated area. So now I got -19 plus 25 gives me 6z equals, this will give me 0. So divide both sides by 6. Z, in fact, equals 0. So now with that being said, I know that z equals 0. So again, I can just pay attention to these two equations. And now that I know z is 0, I can plug it in. So looking at the first one, I got 6x. Actually, what I'm going to do is this. Since it was so easy with x and -x being opposite coefficients of each other, I'm actually going to use these two to help me solve it. Now that I know that z is 0, I can just rewrite this as x plus 6y. And then since z was 0, it's going to be set equal to 23. And then this is going to be -x plus y. And it's going to be set equal to 5. And so I didn't have to write anything more with the z's. So opposite coefficients, this cancels through the elimination method. And now I got 7y equals 28. Okay, so now I divide both sides by 7. 28 divided by 7, it gives me 4. So y equals 4. So then finally, I just go over here, pick any one of these equations. I'm going to pick the middle one. So I'm going to say that x plus 6 times 4 plus 0 equals 23. So now I got x plus 24 equals 23. Subtract 24 from both sides. I get x equals a -1. So my ordered pair in this case is going to be -1 for x, 4 for y, and 0 for z. Okay? And that is being able to solve systems of linear equations with 3 variables. Hope this helps. Until next time.